Okay, Bismillahirrahmanirrahim. Mrs. Sophia Sohail is here. Assalamu alaikum. So last time also I have done the second order derivative. Yeah, second order derivative or second order differentiations. Okay. In this type of differentiation, first you have to focus that our function y exactly dependent on the function x, whether you make that one or if you have two functions, then we have to apply the chain rule. Sometime directly we can find out the dy by dx, and sometime we have to find out dy by dx as dy by something here dx, and here something which variable is involved as a parametric variable, so that will be over here. And with the help of the chain rule, first derivative we find out. Once we find out the first derivative, then repeat the differentiation process as many time it is being asked. Now we have done the last two questions in which x and y was given in the separate functions, and now y is given in this question. Y is equals to e power ax into sine of bx. If you remember, then last time we have done the function e power x and sine of x. What was the easiest thing? That the power is only x and the angle was only x. Here power also have some coefficient and angle also have some coefficient. So whenever we are taking the derivative of this ratio, we have to focus about the angle and exponent also. Okay. So only x variable involved, simply differentiation will help us. Okay. So dy by dx on y, d by dx on e power ax sine of bx. It's okay. Equals to first function, second function. Product rule we can apply. According to product rule, first function we keep as it is and take the derivative of the second function, plus second function as it is and take the derivative of first function. Okay, because the plus sign is here, so we are not putting so many brackets. Otherwise this complete separate and this complete function you can put separate also. Okay, first part and second part. Product rule have two parts. Then this is staying as it is. Derivative of sine is cos of same angle, and then derivative of derivative of bx, which will be b. Until then keep it as it is. And this one, sine of bx as it is, e power ax means stay as it is, and derivative of power or exponent. Okay, it always give me the trouble, it's not going back along with the pages. It's okay. Going back. Okay, let me write down this. Okay, e power ax as it is, cos of bx as it is, and what is the derivative of this? That is b. First part complete derivation is done, plus sine of bx as it is, e power ax as it is, and the derivative of ax is only coefficient a, derivative of x will be 1. Okay, out of these two terms, eax we can take it as common, eax, and here left b cos of bx plus a sine of bx. Okay, so this is the first derivative is done. We can highlight this so we can use it next, the statement which is required. Okay, next is that again derivative of this one, d by dx of dy by dx. Good. D by dx of complete term. Okay, so this is e power ax into b cos of bx plus a sine of bx. It's okay, means complete derivative of that we will write once. Then there are how many functions are there? two functions are there. Okay, so when there are two functions, this is the first function, this is the second function. Okay, so I will write the first function as it is and derivative of the second function, that is b cos of bx plus a sine of bx. Okay, just very smoothly we are going in the differentiation with the simple as much the same rule. Okay, plus second function as it is and derivative of the first function. Let me continue it over here so we are not changing the page. Plus second derivative function as it is b cos of bx plus a sine of bx, and derivative of e power ax. It's okay. Now its derivative, this is constant and derivative of cos will be written here. Okay, first we will keep it as it is external part. Internal part b is coefficient, be careful. When writing the derivative of cos, we can write its derivative minus of sine of the same angle and then derivative of angle, that is b. Is that okay? Can we write like this? Okay. Plus again a is constant, derivative of sine will be cos of same angle bx and derivative of angle will be b. Clear? So until here this derivative is done, means this is the complete derivative of the second function. Okay, now second function was kept as it is, this is kept as it is. Okay, did I take it properly? Okay, then second part, yes. Now we will solve second part as it is, derivative of this we will solve. Okay, plus b cos of bx plus a sine of bx as it is, derivative of this will be ax as it is, only the derivative of exponent, that is a. Okay, so complete step is done. First term as it is means first term as it is, derivative of second term is done, plus second term as it is this and derivative of first term is done. So completely this is done. Out of these two terms, now just check properly that this is the first term and this is the second term. Again we can see this one is common. Can we take it common outside? Yes, so we are writing it common outside, e power ax. Inside I am just putting the big bracket. First this term is there, minus b square sine of bx plus ab cos of bx plus b. What about this a? This a will multiply to both. Okay, ab cos of bx and plus sine of bx. Now they are totally same, so they will be added up. Here coefficient is same, so I can write a square minus b square. I can combine. So my formation will be little simple way. Eax and into this is 2ab cos of bx, and from here if I am taking sine of bx common, I left with a square minus b square with sine of bx. This is my second derivative. Okay, second derivative is this one. Now first derivative also done as here and second derivative also done here. Now they are asking about to make a proof to show that something. So what is that to show? What we have to prove? Show that this is the extra part. Sometimes the paper setter or the examiners are asking like this one. Sometimes if they are not asking, only checking, asking about to find out the second derivative, then our question is done. If they are saying to show something or to give a required statement, then we have to do this part. Okay, so show that second derivative of this y minus 2a times first derivative plus a square plus b square into y equals 0. We can put the respective values. Okay, so first is the value of this one. I will put under the bracket of the pink color. What was the value of second derivative? Complete this. Okay. E power ax into 2ab cos of bx plus a square minus b square into sine of bx. Complete. Done. Then minus 2a. Derivative of first derivative value is this one we write. First derivative value is e power ax and b cos of bx plus a sine of bx. Okay, finish. Second value is done. Means this value I write here. Then plus a square plus b square times the value of y. What was the y? E power ax sine of bx. Okay, it must give equal 0 sign, 0 answer. So let's start solving it and opening the brackets. So we keep on multiplying the parts, e power ax with this one, then with this one. Okay, so that cancellation is possible among the terms. E power 2ab cos of bx into e power ax. Okay, plus a square minus b square sine of bx into e power ax. Slowly we will go. Minus 2a time this one, or first multiply these two terms, or together we can multiply together. Okay, minus sign. Okay, minus sign 2a b cos of bx into e power ax. Okay, now again minus 2a with this one a and a will become a square sine of bx into e power ax. Okay, then again plus a square sine of bx e power ax, then plus b square e power sine of bx e power ax equal 0. Any term is cancelling to each other. This is the first term I saw that is cancelling. Okay, out of all these terms, if we check a square plus a square minus 2a square, b square will be cancelled with minus b square. So out of all these terms, if we can open this one then cancel, or take e power sine of bx and e power ax common out of all these terms. So here left a square minus b square, here left minus 2a square, here left plus a square, and here left plus b square. Is that okay? So this a square and a square cancel with minus 2a square. This b square and minus b square cancel. Means this and this cancel with this one term. So it is left 0 here. So when 0 multiply by anything, it will make it 0 equals 0. So hence our relationship is proved. It's okay. Hopefully you understand, and time is going almost more than 10 minutes. So now the time is saying you to subscribe my channel, and thank you so much. Inshallah, we'll see in the next video.